In this tutorial, you will see how quick and easy it is to create a smart device, a smart LED light that you can control from anywhere in the world using ChipChop. If you haven't done so already, I would recommend that you first have a look at the ChipChop library tutorial. It contains the installation instructions both for the Arduino IDE and Platform I/O. So first, let's open the ChipChop I/O website and let's head straight for the development console. In the development console, in the devices section, we need to add a new device. We are basically creating a virtual representation of the device we are going to build so that the ChipChop engine knows how to communicate with it. And this is going to be a physical device, so we'll choose real device. We need to give it a name. I'm going to call this one Smart LED. And then we need to specify a unique ID. A unique ID can be anything as long as it's genuinely unique between your devices. What I normally do is I call it the same name, just all lowercase and underscore instead of space. And this is going to be a simple device. It will just have one component, an LED light. And as a type, we can either set it as a light type or on and off, because technically it can also be specified just as an on-off. It can be switched on or off. I'll choose light. As a mode, there are two options, view only and interactive. What those two mean? View only is used for components like sensors, where we can view their status, they can tell us their readings, but we can't force them to change it to something else. So, for example, a temperature sensor, we can check its reading and what the temperature is, but we can't tell it now that it's something different. That's not how that component works. On the other hand, the interactive mode is for components that we interact in some ways, either by physically interacting, so we have a push button and we can press it, or in this case we will be sending remote commands and telling this LED to switch itself on or off. So I will choose interactive mode and then make sure to press update. You can have up to 10 components per device. Just repeat the process. In this panel, we have a bunch of JSON example strings, what you should be sending from your device and what your device can expect to receive back. This really only applies if you're not using the ChipChop Arduino library. So if you are communicating through something like Raspberry Pi or a Node.js app, then these are really useful as a reference what you need to send or what you can expect to receive back. And finally, don't forget to press the save. Okay, so if we go quickly into the live control section, we can see now our little device here, but there's nothing to display because it's not built yet and we never sent its status. Once we get it connected, then we will be able to see its status here and also be able to interact with it either from this development console or from the web app. So if we go into the download section now, if you haven't downloaded the library yet, this is the place, one of the places you can find it, the source code for it, and also you have the link to the tutorial and the documentation page. So I'm going to download the library and I'm going to unzip the download, and here it is. We have the actual library folder that also contains the examples and the source code, and we have the folder with the WebSockets library. This one is only needed if you are using Platform I/O. So I'm going to open VS Code and I have Platform I/O ready here, and I need to create a new project, and I'm going to call it Smart LED. I need to specify a board. I'm using an ESP8266, so I'll use this generic board. And here we go. Platform.io has created now a blank project. And if we look under my user documents in the Platform.io, we have the Smart LED project ready for us. All we need to do now is copy the downloaded ChipChop folder and WebSockets library files into the lib folder, so they will be included now with this project compilation. And back into VS Code, and in the source here we have the main CPP file that we need to edit to write our code in. And what we are going to do now is go into the lib, ChipChop examples, Smart LED, open the file, select all, copy it, and then simply replace the main CPP file. So we can now start editing the code. First thing we come across are the security credentials and the device ID. We know that one already. It's smart_LED. For these security credentials, the quickest way is to go back into the development console, my account, and here they are. Simply copy them, go back and replace these. Next bit is the command callback, which is defined here. This is the part of your code that will receive any commands that you will send either through the web app by pressing a button, or through the development console, or through some automated action. We are checking that the target component is called LED. You can have multiple components and each one can receive different type of commands. And then if the command value is on or off, we are just going to store that command in a string variable LED status, so we can send it back every 10 seconds, the status of this device, so we can see it remotely. And then finally, we are actually writing digitally to this pin and switching the light on or off. In the setup, I need to specify my Wi-Fi credentials, and I'm going to put my super secure password that no one can guess. Now we are telling the ChipChop library where the command callback is, and we are going to start the library itself by passing it the security credentials. I've also set the debug flag to true. It's quite interesting to watch the messages that are bouncing backwards and forwards between your device and the ChipChop engine once it's connected every few seconds. Finally, we have the main loop. It's absolutely critical that you keep the ChipChop library running through the main loop, not just to run the library itself. The library runs the WebSockets, and you should avoid using the delay function because that could block the WebSockets. So instead, you should use a technique like this, where we have a non-blocking check every 10 seconds. And if we're connected to the Wi-Fi, we're telling the library to update the status of this particular component to this particular variable. But that's about it. So I'm going to run a quick build to make sure that this all compiles okay and that there are no problems. And let's see. Yep, we have success. And now I'm going to push this onto the real device. And here we have a very simple LED on the breadboard with an ESP8266. And if we go now to my ChipChop.io, Under devices, we have our little LED showing there. And if we click the on button, oh, there we go. This will work anywhere in the world as long as you have Wi-Fi. So you can put that LED on a different continent, and you can be on a completely different continent. And this is the speed of how quickly things happen. I hope you have enjoyed that, and good luck creating your first smart LED.